a massive scarlet star, one of the brightest and most easily identifiable stellar bodies, dominates the vast expanse of the celestial sphere. It is located far beyond our full understanding and has the capacity to release an energy magnitude that could rival the combined radiance of an infinite array of stars. This cosmic monster, which may be on the brink of apocalypse, could soon release an explosive explosion so powerful that it could eclipse 1 billion suns. The true question is, are we ready for the fallout that such an incident might bring about? Neil deGrasse Tyson is a huge red star. Goliath is a star that is relatively close to Earth and has generated a lot of interest and discussion among scientists and the general public. More recently, this star underwent a significant transformation that raised concerns among researchers and sparked conversations about its future course. The most concerning hypothesis is that this change could be an early warning sign of a supernova. If Alpha Orionis, the technical name for this star, were to run out of nuclear fuel, it may collapse under its own gravitational attraction, causing a catastrophic explosion. This is an explosive stellar occurrence that marks the final phase in a star's life cycle. The mere notion of such an occurrence causes worry among scientists, as well as the rest of us who live on Earth, since the possible outcomes might be astounding. Alpha Orionis can be quickly identified by its deep crimson hue. With the use of cutting-edge instruments like NASA's Hubble Space Telescope, it is recognized as the largest and most radiant star in the Orion constellation. Astronomers have kept a careful eye on its behavior, especially in 2019, when it had a sharp mass reduction. Why is Betelgeuse unique, and what is it? Its behavior is thought to be uncommon for stars of this kind, alarming the scientific community worldwide. As our Sun regularly experiences coronal mass ejections, there is now disagreement among scientists on the exact distance of Alpha Orionis from Earth. Some believe it to be 1,200 light-years away. This is because of the unique event that was observed in Alpha Orionis, which has caused a reevaluation of what happens during the late stages of a huge star's existence. Others, however, contend that it could be as close as 724 light-years. The difficulty in accurately determining the position of stars like Alpha Orionis lies in the immense distances involved and the peculiar nature of red giants. Despite uncertainties regarding its precise location, Alpha Orionis continues to captivate observers as one of the most awe-inspiring objects in the night sky, shining several times brighter than our Sun. However, this radiant glow comes at a significant cost. Alpha Orionis is consuming its nuclear fuel at a rapid pace, which accelerates its journey toward the inevitable end of its life cycle. Once it exhausts its fuel supply, the star will likely collapse, possibly forming either a neutron star or, in a more catastrophic scenario, a black hole. The question of whether Alpha Orionis could be a threat to Earth depends on how the explosion plays out. If a supernova were to occur within a few light-years of our planet, the consequences would be catastrophic. Supernovas can release an unfathomable amount of energy, possibly surpassing the entire galaxy's output, with the potential for profound effects. Even though Alpha Orionis is located far from Earth, historically, the last known supernova event in our galaxy occurred in 1604, and humanity has not seen a similar event on a local scale since. However, in 1987, a massive supernova erupted in the Large Magellanic Cloud, which is located an astounding 169,000 light-years away. Although this explosion had significant effects on its immediate environment, it did not directly threaten Earth. Nevertheless, these infrequent occurrences serve as powerful reminders of the enormous scale of supernova explosions and the risks they may pose. A supernova, especially one that occurs near Earth, could create what has been called a danger zone around the stellar explosion. However, given the frequency of supernovae, the threats to life on Earth should be considered within the larger framework of cosmic events. A far greater hazard is posed by gamma-ray bursts, GRBs, which can destroy entire planetary biospheres and flood them with lethal radiation. For example, GRBs might obliterate a planet's ozone layer, leaving it vulnerable to harmful cosmic radiation. This imminent threat of gamma-ray bursts has drawn attention from recent research, which has shed new light on the potential hazards associated with stellar explosions that culminate in such dramatic and destructive events. When massive stars explode as supernovae, their brightness can surpass that of entire galaxies. This intensity raises an important question. How will this affect Earth? If Alpha Orionis were to undergo such a transformation, it might become the second brightest object in the sky, second only to the Sun. While the visible light emitted by a supernova would certainly be a striking sight, the energy released in such an explosion might be so intense that it could be visible even during daylight hours. This blinding spectacle would cast shadows in the middle of the day, giving those who witnessed it a startling yet unnerving experience. The high-intensity radiation that follows such an explosion poses the true hazard. This radiation, usually in the form of X-rays and gamma rays, would have far-reaching effects. Its ability to destroy Earth's protective ozone layer is one of the biggest worries. Without the ozone layer, life on Earth would be exposed to dangerously high UV radiation levels, which could result in extinction events. The risks posed by a supernova never go away. The remnants of the explosion, such as shock waves that travel almost the speed of light, would continue to be dangerous as they spread throughout the solar system. These shock waves could further destroy the ozone layer, putting Earth at even higher risk of dangerous radiation, which would only increase the risks over time. Some studies indicate that Earth may have already experienced the fallout from a supernova explosion in the past. Elevated levels of iron-60, a radioactive isotope produced in supernova explosions, have been detected in deep-sea sediments and lunar soil. This suggests that Earth has likely encountered the fallout from such an event within its geological history, possibly within the last few million years. At this time, there are no known supernova candidates near Earth that pose an immediate threat, but ongoing research is constantly uncovering new potential threats, especially from supernovas that can emit long-range radiation. Supernovas are created when a dying star collides with a massive disk of material around it. The shock waves from the explosion interact with the material to create intense X-ray radiation that can travel great distances through space and potentially affect planets within 150 light-years. Fortunately, no such candidates have been found in our area, but this research has provided new perspectives on the idea of the habitable zone. It appears that the area of space where life-supporting conditions might exist may be more constrained than previously believed, with outer portions of galaxies showing insufficient star formation activity to sustain the construction of rocky planets. However, the interior areas, where stars are created and die more quickly, may pose concerns because supernovas occur frequently. As researchers continue to study the remnants of supernovas, they are learning that these cosmic remnants have the potential to produce new stars by creating stellar nurseries from the material that was expelled. Supernovas are not just destructive events. They are also essential in the formation of the very elements that comprise the stars and planets we see today. Additionally, by observing the brightness of Type Ia supernovas produced by a white dwarf's explosion in a binary system, researchers have been able to measure cosmic distances with remarkable precision. These standard candles have transformed our ability to map the universe, providing vital information about dark energy and the accelerating expansion of space. Moreover, the study of supernova remnants provides insights into the origins of heavy elements essential for planetary formation and life itself. The material ejected during a supernova explosion enriches the interstellar medium, forming the building blocks for new stars, planets, and even biological processes. As a result, while supernovae are powerful and destructive, they are also vital to the ongoing evolution of the cosmos. Scientists continue to analyze supernova events to determine their long-term impact on cosmic structures and planetary systems, helping us understand both the dangers and benefits these cosmic cataclysms bring. Supernovae have also provided astronomers with a method for measuring vast cosmic distances. Type Ia supernovae, in particular, are used as standard candles to gauge the expansion of the universe. These predictable explosions allow scientists to determine distances between galaxies with remarkable precision, offering critical insights into dark energy and the accelerating expansion of space. By studying the remnants of these stellar deaths, we continue to refine our understanding of the universe's past, present, and future. In addition to their role in cosmic evolution, supernovae contribute to the diversity of planetary systems. The elements they disperse into space shape the composition of newly formed planets, potentially influencing their habitability. Without the contributions of past supernovae, Earth itself would lack the essential elements required for life. Thus, while these celestial explosions may pose potential threats, they are also indispensable in shaping the universe as we know it.